Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today I'm going to solve some numericals on the quantum theory. That's about the energy of a photon, and I will evaluate the energy of photon in terms of frequency and the wavelength of a photon. So I'm writing first the formula that I'm going to use to solve certain numericals. So first of all, I'm writing the energy of a photon. The energy of a photon is equal to the h nu, where nu is my frequency. We have done this thing in the previous lecture, and it can also be represented like the energy of a photon is equal to the h c by lambda, where lambda is the wavelength. Now, what is h over here? H is Planck's constant. The h is Planck's constant, whose value is 6.626 into 10 to the power minus 34 joules second. Here nu is frequency of the wave of photon, frequency, and here wavelength, the lambda is wavelength. The lambda is called wavelength. What's the value of c? What is c actually? It is the speed of light. Speed of light, whose value is 3 into 10 to the power 8 meters per second. So these are the formula that I'm going to use in solving these numericals. Now, question number 1. The question number 1 is saying, calculate the energy associated with a photon of light having a wavelength of 6000 angstroms. So I'm writing the wavelength given over here is 6000 angstroms. Now you have to convert this 6000 angstroms to a SI unit, that is in meters. It comes out to be 6000 into 10 to the power minus 10 meters. So that's my wavelength. Now let's talk about the energy of photon. The energy of photon, the formula is h c by lambda. Now what's the value of h? It's 6.626 into 10 to the power minus 34. What's the value of c? It's 3 into 10 to the power 8 divided by how much wavelength is given? It's 6000 into 10 to the power minus 10, that's in meters. So the energy of photon here comes out to be 3.313 into 10 to the power minus 19 joules. So hopefully my dear students, you got the first numerical. It was a very easy one. You have to just substitute the values of h, c and lambda, and you have to evaluate the energy of photon. So now let's move to the next numerical. Is the second one. Calculate the energy of 1 mole of quanta of radiation whose frequency is 5 into 10 to the power minus 10 per second. Now, first of all, what is given to us? It is the frequency. The frequency is nu. Its value is given to be 5 into 10 to the power 10 per second. So that's my frequency. Now let us calculate the energy of one photon. I'm writing energy of one photon, that is EPH. It is h nu. Now what's the value of h? It's the Planck's constant. Its value is 6.626 into 10 to the power minus 34. What's the value of frequency? It's 5 into 10 raised to the power 10 per second. So the energy of one photon comes out to be 33.13 into 10 raised to the power minus 24 joules. Now in the question is asking about the energy of 1 mole of quanta or the 1 mole of photon. So how many units are there in 1 mole? Is 6.022 into 10 to the power 23. That's the Avogadro. So I'm writing energy of 1 mole of photon or quanta is the same thing. The energy of 1 mole of photon will be energy of 1 photon into Avogadro constant. It's 6.022 into 10 to the power 23. So that comes out to be the energy of 1 mole of photon. So what's the energy of 1 photon that we have calculated? Is 33.13 into 10 to the power minus 24. What's the Avogadro constant? Is 6.022 into 10 to the power 23. So this value comes out to be 19.95 joules per mole. So what I have done in this numerical, I have evaluated the energy of one photon. Then I know that 1 mole of quanta or 1 mole of photon will have 6.022 into 10 to the power 23 photons. So this much number of photons, that's the Avogadro number of photons into the energy of 1 photon, will give me the energy of 1 mole of photon. That comes out to be 19.95 joules per mole. Hopefully you got the second numerical also. So now let's move to the third numerical. Now the third numerical is saying compare the energies of two radiations, one with the wavelength of 6000 angstroms and another with the wavelength of 3000 angstroms. So we have to compare their energies, or we have to find a ratio of their energies. So I'm writing in a separative way. I'm writing first radiation over here, first radiation, and here I'm writing second radiation. Now what's the wavelength for first radiation? It comes out to be 6000 angstrom. Now what's the wavelength for second radiation? It comes out to be 3000 angstrom. So these two values are given in the question. So now let's talk about the energy of the first radiation. The energy of first radiation comes out to be Hc by the wavelength of first radiation. The energy of second radiation comes out to be Hc by wavelength of second radiation. Because H and C are the constant values, so I have not written 1 over there. The wavelength is variable, so I have written lambda 1 and lambda 2. Now what I have to do? We have to evaluate their ratio. So I am writing E1 divided by E2. It comes out to be Hc divided by lambda 1 divided by Hc divided by lambda 2. It comes out to be Hc divided by lambda 1 into lambda 2 divided by Hc. So this thing comes out to be lambda 2 divided by lambda 1. So the relation comes out to be E1 divided by E2. It comes out to be lambda 2 divided by lambda 1. The lambda 2, it's 3000 angstroms given in the question, divided by lambda 1, its value is 6000 angstroms, is also given in the question. So it comes out to be 1 divided by 2. So the ratio comes out to be E1 is to E2. It comes out to be 1 is to 2. So that was the third numerical. Please do have a look. Now let's move to the next numerical. Now what's the next numerical is saying? The 3 into 10 to the power 18 photons of certain light radiation are found to produce 1.5 joule of total energy. Calculate the wavelength of the light radiation. So first of all, I'm mentioning how many number of photons are given over here. So I'm writing number of photons. It comes out to be 3 into 10 raised to the power 18. Now, what's the total energy given in the question? I'm writing total energy is given to be 1.5 joules. What we have to evaluate? We have to evaluate the wavelength. So I'm writing wavelength with a question mark. So I'm writing how we will evaluate it. I'm writing here total energy will obviously be equal to energy of one photon into the number of photons. My dear students, total energy is given to be 1.5 joules. Energy of one photon we don't know. How many number of photons are here? Is 3 into 10 raised to the power 18. So now 1.5 divided by 3 into 10 raised to the power 18 comes out to be the energy of one photon. It evaluates to 5 into 10 to the power minus 19. It's equal to the energy of one photon. So energy of one photon is equal to the hc by lambda. So I'm writing 5 into 10 to the power minus 19. I'm substituting the values of h and c. It comes out to be 6.626 into 10 to the power minus 34 into what's the value of c is 3 into 10 to the power 8 divided by lambda. Now my motive was to evaluate the value of the wavelength. So wavelength comes out to be 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 5 into 10 to the power minus 19. So the wavelength comes out to be 3975.6 into 10 to the power minus 10 meters. Or you can simply evaluate to the angstrom. So it comes out to be 3975.6 angstroms. So that was my fourth numerical. It was also an easy one. Now let's move to the fifth numerical. Now was the fifth numerical is saying. An ultraviolet photon of wavelength 300 nm is absorbed by a gas and then re-emitted as a two photons. One photon has a wavelength of 760 nm. So what would be the wavelength of other photon? So I'm writing this is a gas molecule. This gas molecule absorbs one photon whose wavelength is 300 nanometers, and then this gas molecule emits two photons. I'm writing first photon over here and second photon over here. The first photon will have the wavelength of 760 nanometers. Let it be lambda 1. It comes out to be 760 nanometers. Now lambda 1. Now the lambda 2 we have to evaluate. So hopefully my dear students, you got the situation. The question is saying that a gas molecule absorbs one photon whose wavelength is 300 nm, and then that gas molecule emits two photons, the one with the wavelength of 760 nm and the wavelength of second we have to evaluate. So how will we do? How will we solve this numerical? Let it be the first photon with the energy of E1, and let's assume the energy of second photon to be E2. So I'm writing energy of photon will be equal to the E1 plus E2. So let's substitute the formula. Energy of photon comes out to be hc by lambda. This thing comes out to be E1 comes out to be hc by lambda 1, and energy of second photon comes out to be hc by lambda 2. Let's cancel out the h and the c. We got a situation, we got my equation to be 1 by lambda comes out to be 1 by lambda 1 plus 1 by lambda 2. Now what's the total wavelength given over here? The total wavelength is 300 nanometers. So 1 by lambda it comes out to be 300. It is equal to 1 by, what's the lambda 1 given in the question? It's 760. So this comes out to be 760 plus 1 by lambda 2. So it comes out to be obviously 1 by 300 minus 1 by 760 equal to 1 by lambda 2. It comes out to be further 760 minus 300 divided by 760 into 300. I have taken the LCM. It comes out to be 1 by lambda 2, and now the lambda 2 comes out to be 495.6 nanometers. So this was also a very easy question. Hopefully my dear students, you got the fifth numerical also. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.